So the next presentation is about Transhierarchy, a stable tree view with transclusion for hypertext navigation. The authors are Raine Revere and Jamie Bluestein. Raine is a software engineer, psychotherapist, and interaction design researcher. She's a dedicated meditation practitioner in the Tibetan and Zen Buddhist traditions. Her contemplative meditation experience is the basis of a uniquely phenomenological approach to interaction design. Her current focus is the design and development of a process-oriented semiotic note-taking app for personal sense-making. She currently works as an independent researcher and designer at the Cyber Semics Institute based in Denver, Colorado, USA. So thanks, Raine, for presenting Transhierarchy to us.
Hi, everyone. It's a pleasure to be here. Really excited to share this work with you. I'm presenting on behalf of myself and Jamie on the topic of transhierarchy. And give you a brief overview. I'll define transhierarchy and show you what it looks like first, and then take a step back and talk about our approach, defining the problem. And then I'm going to show you, I'll go through a detailed set of steps for how transhierarchy works, and also show some examples in the wild. I developed an application that demonstrates transhierarchy, and it's also observable in several commercial applications. So it's an important technique to be aware of. Transhierarchy we've defined as a method of navigating hypertext within a stable hierarchical user interface. And I'm going to come back to this and talk a little more about the hypertext versus hierarchy distinction and why it's important to create a stable user interface for navigation. Just so you have a preview of what I'm going to be getting to, this is what it looks like. Looks like a pretty standard tree view with indented text, but this is actually representing nonlinear hypertext, and I'll explain how that's possible. So first, our approach. This was technical research. So firstly, our approach is algorithmic, describing exactly how this technique works. And next, it involved a survey of existing software that demonstrates this. It does not include user research, and that would be the next obvious step. So back to the definition. The main points to contrast here, you're already familiar with hypertext versus hierarchy. Hypertext, as we know, most broadly represented as a graph in the mathematical sense with any number of nodes connected by edges. In our model, we consider hypertext graphs with directed nodes, directed edges, rather, from any node to any other. Hierarchy, I use that term synonymously with a categorical or tree view. That's actually a subset of a directed graph or a subset of a graph in which a child node only has a single parent node. So this is one of the limitations that we're facing, is that hierarchy is fundamentally a subset of a graph or hypertext. Now, why would we try to represent hypertext in the form of hierarchy? Well, hierarchy is a widely used and in many ways prevalent and intuitive way of looking at data and organizing information. Hypertext itself has faced challenges in how to represent hypertext in an understandable way for users. One of the biggest challenges has been what's called the disorientation problem, or the lost in hypertext problem. And that is the fact that a graph where a user can take any path through the nodes doesn't have a definitive start point or end point, doesn't have stable relationships between the beginning and the end and the course that's taken. Hierarchy, on the other hand, when data is possible to be presented in a hierarchical form, it's a very straightforward and stable structure. By stable, I mean that the spatial relationships between the nodes or between the pages or nodes that the user is navigating, maintain a structure that the user can rely on, that would be analogous to navigating physical space and having things be in the same place that you left them. Hypertext, as we know, is a much more diverse structure and able to capture a more general set of information. One of the things that we have wanted to address is how to take advantage of the intuitive navigational properties of hierarchy while having access to the flexibility of hypertext. Few precedents I just want to quickly mention. This topic has been explored in much of the structural hypertext research of the 80s and 90s. Foss described a history tree view, which represents hypertext in a tree view using a history of the user's actions, very similar to transhierarchy. Others, like Schaffer, have taken the approach of representing hypertext in a graphical form, but using node clustering to compress that hypertext and without a tree view, being able to minimize and collapse sections. And then lastly, some of the best research in this area was done by Wang and Rada on their Much system and subsequent Rich systems, which tackled this question pretty directly. They ended up running into difficulties where their layout algorithm would change the structure of the hypertext for the user if the underlying graph changed slightly. They recognized that as a stability problem, part of the disorientation problem. And their proposed solution towards the end of their research was to add a semantic layer to help disambiguate those situations. Now, we've specifically avoided additional semantic constraints. There's been good research on the limitations of requiring users to add semantic constraints, the additional cognitive load and work of that, as well as the inconsistencies. So our approach is a general approach of representing hypertext in a hierarchical form without any additional semantic requirements. So what we're going for in the combination of hypertext and hierarchy, we hope to capture the benefits of each of them. And these can be summarized as stability, as I mentioned, navigational stability. And one I haven't mentioned, but is extremely important, is compactness. So the compactability directly influences whether a hypertext can be navigated on a small mobile device. Now, this is an area that I think has been neglected by the hypertext community to some extent. I say neglected because the majority of web traffic and interaction with hypertext is in the mainstream is through mobile devices. And yet many of the demonstrations and applications created within the academic community are desktop only. So if we can develop a technique of representing hypertext that is easily displayed on a mobile device, that is a huge gain. Lastly, our technique takes advantage of transclusion, which I will just define as inlining linked content instead of jumping to that content. This was advocated early on and coined by Ted Nelson, and contributes to the continuity for the user, being able to navigate through multiple nodes without jumping from place to place, thus contributing to the disorientation problem. So now I'm going to do a detailed description of how transhierarchy works, the algorithm for it. And this is mainly taking examples from M, the application, the note-taking, nonlinear note-taking application that I developed. So on the left, you'll see a representation of a graph. It's been organized to look like a tree, but you'll notice there's an incoming edge from C1 to B, in addition to the top-down A to B. So this is a nonlinear graph that can't be represented by a strict hierarchy. On the right, you'll see a standard tree view of the first three nodes. So the way that transhierarchy works is that it starts at a given node in a graph. Again, that we're assuming directional edges between nodes. And using that graphical form presented in figure 1A here, we can expand node B and view the children B1 and B2. So figure 2A on the left, again, shows a standard tree view of this graph following outgoing edges along the graph. Figure 2B on the right shows transhierarchy, or the transhierarchical view, which simply consists of replacing the child nodes at a given level with incoming edges instead of outgoing edges. And in the M application, this is represented under the label contexts. So these are actual screenshots from M. So the main difference being that the user has to take an action. They activate the transhierarchical view at any given node. And then they're switching from viewing outgoing edges, B1 and B2, to incoming edges. You can see on the right, those incoming edges are A and C1. And just to show you, those are indeed the incoming edges to node B. So to show you the power of transhierarchy and its fractal nature, let's go one level deeper. So in figure 3A, this is the same graph all the way down to the bottom level. X, Y, and Z were added. Figure 3B on the right shows the transhierarchical view activated again for node B, so that the user is viewing incoming edges A and C1. Now, when the user highlights C1 or selects it with their cursor, then it expands to show the children, the outgoing edges of C1, X, Y, and Z. So if you look at this overall pattern, we're following outgoing edges and then activating the transhierarchical view, viewing incoming edges, and then it resumes the normal view of outgoing edges. So this is a powerful way to navigate any graph following incoming or outgoing edges. And it fits in this traditional tree structure, which for textual data is very compact and easily represented on mobile devices. Okay, so what does this look like in a real world application? This has very pragmatic use. I use it personally, and as I will show, it's being picked up by the outliner and note-taking communities, and there's some exciting developments in that area. But what does a real-world example look like? Here are notes that I took during the lit review for this research. And the history tree interface, as you recall, was one of the historical precedents by Foss. And this screenshot shows the history tree interface node in the transhierarchical view. There's a superscript that is a hint for the user to show how many contexts or how many incoming edges they are. So that would be visible even when they didn't have the transhierarchical view activated. You can see the 3 contexts or the 3 incoming edges here. These are actually 3 different papers in which the history tree interface was mentioned. And again, following the same inversion from outgoing to incoming to outgoing, this view is showing the notes that I took regarding history tree interface in each of these papers. So these aren't just all of the notes of those papers, they're specific to the history tree interface. So this method of rendering a graph in transhierarchical view has a very practical ability to provide cross-cutting viewing patterns of hypertexts. I'm able to reference a history tree interface in any place in the graph and then activate the transhierarchical view to see all of the places that it was referenced and the relevant notes. Okay, so next I want to show you some examples of transhierarchy in the wild. This is quite exciting because it's a technique that has been picked up and used in industry. The first example I'll show is a tool called ThinkTool. And I've actually reproduced the same content from this history tree interface shown in M. So the exact same content, you'll see how similar it is in ThinkTool. Instead of contexts, they call them references. We're at the history tree interface node, and indeed there's 3 incoming edges. Some of the way they're represented is slightly different. The main node history tree interface seems to be repeated several times, but this tool also uses transclusion to bring in the notes from each of those items. So very similar. Next is a tool called Rome. And here you can see almost an identical representation of hypertext that has backlinks, and representing those incoming edges or backlinks, they call them linked references. And again, they use transclusion in order to pull in the content from each of those links. So what's striking for me is how similar these techniques are. It's likely that ThinkTool was developed with knowledge of Rome, but I can say personally that I developed M, started development 2 years ago, and it was before I was aware of Rome. And there are others like Workflowy. So there's, I think it's significant that there's a convergence of several of these note-taking tools that are embracing backlinks and embracing hypertext structure and finding ways to do that within a traditional tree interface. I want to take just a side note to mention, if you're wondering why this is important, Rome, for example, just received funding with a $200 million valuation. This is a huge new wave of note-taking tools, and it's getting mainstream attention. And something that the hypertext community has been talking about for decades. This is really significant that there is a way to connect this with industry and the mainstream movement. And I believe that hypertext researchers have a lot to say about this. So a few limitations to be aware of with Transhierarchy. One is that, as you can see, it's highly textual. And while you can embed images and videos, it's not clear that a very media-rich hypermedia document would necessarily be best served by Transhierarchy or without additional modification. Another limitation is that another limitation is that the structure of Transhierarchy favors outgoing links, because you have to show either outgoing links or incoming links. It defaults to outgoing links, and then the user has to activate the transhierarchical view. It's simply a key command or a button click, but I would guess that if there was a use case where the user was mostly navigating incoming edges, then Transhierarchy wouldn't be the best fit. And then lastly, there's a lot of potential challenges based on user research that has not been conducted. And one of the challenges I've anticipated is that by replacing child nodes in the tree structure with parent nodes or incoming edges, we've changed a really fundamental invariant to the tree structure, and users expect to see child nodes indented. So the fact that it's showing parent nodes indented could be confusing and add to the learning curve. So in conclusion, we have presented a technique for representing nonlinear hypertext in a somewhat linear hierarchical form that is easily shown on mobile devices, is stable, in other words, provides reproducible deterministic layout of hypertext depending on the user's navigational patterns, and takes advantage of transclusion to inline content. And I showed a few other tools, namely Rome and ThinkTool, that show that this technique is being actively used in industry today and that it deserves attention from the research community. I am excited to answer your questions and open it up for discussion now. Thank you so much.
Yeah, thanks a lot for your very good presentation, Raine. So, do we have any questions? Maybe I can ask the first one, which I was thinking of while listening to your talk. So, if I think about hierarchy, I have something formal in mind. So, if you talk about transclusion, it would mean that one node could actually occur on different places. In a very strange case, you could create circular structures. So would you agree that this is a different way of presenting network structures, because you can easily compare your hierarchy, including the transclusion, as generic network structures, in which you do not take much care about the semantics of parent and child, because this is a very specific semantics in hierarchies, certainly. And you could argue, well, we are not considering this in our networking structure. So you could actually render any network structure as, transclusion hierarchy, transhierarchy. Would you agree?
Yeah, absolutely. It's a general approach that will work on any graph. That's a good point about cycles, and this was specifically designed to handle cycles, and that's part of the reason that I'm presenting it here at the Human Factors workshop, is because it's not a description of an abstract data structure. It's a description of a navigational technique, and it relies on the fact that the user's only going to be looking at a certain amount of information at a time. So cycles aren't a problem because the user is only looking a few levels deep. So you can toggle back and forth between the normal view and the transhierarchical view. You can follow cycles. And because it's that more user-centered navigational approach, rather than a more abstract data approach, the cycles aren't a problem, and it works for any data structure.
Do we have any other question?
Oops, put my hand in the right place.
Yeah, Mark?
Thanks. Super. I was writing comments. So it's really nice to hear this explained, because I've sort of seen this turning up as Rome, the so-called cult of Rome, where it's all treated as some wonderful new thing, whereas the hypertextual community, as you pointed out, this is sort of, breathing new life into things we already knew. I just wonder, so what stage is your sort of tool at? Is it something that one can try out?
It's not publicly available yet, but I have devoted quite a bit of resources to developing it. It's sort of a hybrid between a commercial application and a research application. It's open source. It's funded by a nonprofit that I founded, and it'll be available within the next year.
Cool. And good luck with the project.
Thanks.
Do we have any other question?
I think there was one in the chat.
I didn't see that one. All right. This one. Peter's asking, did you consider extending the incoming edge view with transitivity to show the entire inbound hierarchy? That is higher order inbound links.
Yeah, great question. So if I'm understanding this correctly, the transclusive view, the transhierarchical view, shows the notes from the incoming edge that are just related to that topic. And I agree that there's a practical need if users are truly exploring a hypertext and navigating it freely, to be able to expand and see more of that incoming edge. So just informally, I've explored some possibilities where initially it shows just the immediate child nodes of that transcluded node, but that you could, it would show sort of like a series of breadcrumbs that you could use to expand further and further out, all within that that transcluded section. I realize that's kind of hard to explain with words, but it's a great question about kind of how this technique can be expanded so that it really allows for free form navigation by users. Yeah, I agree.